Okay, cool. So let's continue. So we're going back to products. We have with us now Dr. Xinrui An, who is R&D Manager at Jietai, also called JTPV. And he will talk about unlocking BOS cost reduction in distributed projects with high efficiency solar cell technology. Xinrui, the floor is yours. Hey.
Thanks, Michael. Can you please help put up the slides for me? Because I don't have it on my mobile. I talked to Sandra.
Okay.
Hello, everyone. I'm Xinrui from JTPV. It's a great honor for me to share our latest N-type cell technologies and explain how their high efficiency and reliability can contribute to BOS cost reduction for distributed PV projects. Oh, that's my image? No? I lost my image. Anyway.
No,
okay, so today's
there.
talk.
Yeah, okay. Yeah.
Okay, maybe it's just me that can't see it. Today's talk will cover the following sections. I'll first give a bit of introduction about the global market for renewable energies, especially PV. Then I'll discuss in detail about our N-type cell technologies with emphasis on advanced metallization and half-cut edge passivation, followed by some results about our cell and module performance, as well as their reliability behaviors. And finally, I'll give some updates about our R&D progress in BC technology and a brief introduction to our company. Next slide, please. Oh, sorry about the format because it changed to PDF. From 2021 to 2024, photovoltaic has been expanding at a unprecedented pace. It tripled in its annual installed capacity from 160 gigawatt to nearly 500 gigawatt. And according to IEA, this number will continue to grow in the following years and exceed 700 gigawatt by 2030. This will make PV the dominant renewable energy type with more than 70% market share. So next slide, please. Region-wise speaking, the China market will be contributing to roughly half of all the new PV installations till 2030 due to its large electricity demands and ambitious decarbonization goals. Emerging markets such as India and the Middle East will also have significant contribution to new PV installations, and the total annual installed capacity will approach 1 terawatt, according to Bloomberg. Next slide, please. In terms of cell technology, TOPCon has already replaced PERC as the dominant technology type since 2024 and remain in dominance for another 5 years, according to CPIA. Although competing technologies such as HJT and BC will likely gain popularity for certain application scenarios. For instance, BC may be more favorable for CNI rooftops due to its superior front-side efficiency, while HJT will boast in its lower temperature coefficient and higher regeneration, thus more suitable for hot and high albedo environments. Next slide, please. Okay, now let's move to the technical part of our N-type solar cells. Next slide, please. The technologies here form the backbone of our N-type cells branded as Mono 1 cell, and I'll briefly talk about them one by one in case some of you are not familiar. First, the stack wafer depot process is the cornerstone of our N-type cells as it can be applied to several different thermal processes, during which a pair of wafers sit back-to-back to receive single-side diffusion or deposition, and the undesired wraparound layers can be removed with single-side wet chemical etch. And the second one, the emitter metal contact optimization, is an upgrade to the standard selective emitter technology, which drastically reduces genome metal to below 100 femton per square centimeter without forming heavily doped contact regions. And this can lead to more than 5 millivolt increase in VOC and 0.3% enhancement in cell efficiency. And the third, the gradient index and reflection coating involves multiple layers of silicon nitride layer on top of very thin aluminum oxide. Specific adjustments to silicon nitride layers allow for tremendous UV-ID reduction with minimal efficiency loss. And UV60 of about 1% can be achieved. And the super thin fingers and super multi-bus bars are similar technologies for metallization. Both are applied to enable thinner and more closely spaced contacts. As a result, high cell efficiency and lower silver consumption per watt can be achieved to further strengthen the cost effectiveness of our products. Next slide, please. So on top of Model 1, which is standard and mass-produced cell, I'd also like to introduce 3 relatively new technologies applied to our premium half-cut product, the Mono 2 cell. The first one is the super thin finger plus technique, which is shown here. It further reduces silver finger width to below 15 microns from 20 microns. It allows for higher emitter shift resistance with smaller finger spacing, and consequently rebalances the relationship between VOC, JSC, and fill factor for the cell. Generally, this leads to a shift towards higher VOC and efficiency devices, as well as reduced silver cost per watt. The change might seem quite straightforward, but it took us a lot of effort to bring this super thin finger plus technique into mass production. Practical problems such as the finger abrasion due to reduced finger width were overcome with well-designed screens and optimized printing processes. We not only pursue narrow fingers, but also more uniform cross-sectional profiles for the fingers as well, because it can lead to lower line resistance for the fingers. Next slide, please. With super thin finger plus, we can see a 0.3% increase in fill factor and about 0.1% efficiency gain without any significant change in VOC or JSC. This is due to improved finger aspect ratio from 50% to nearly 70%. Alternatively, we can also use higher shift-resist emitters to increase the VOC at the cost of fill factor, as you can see from the third row of the table. Though the second approach has the same efficiency gain, it could be beneficial for module suppliers with slightly better CTM. Next slide, please. Oh, I can't see the word. Sorry. So another important feature for the so-called half-cut edge passivation. Our R&D in this technology began in late 2023, and now it's applied to our premium Mono 2 cells, which are available for selected customers. Because almost all the PV modules now are made from half-cut cells due to lower resistive losses and higher power output, the lack of passivation at the laser cut edges may result in higher edge recombination and lower pseudo-fill factor for the cells. And as a result, 0.2% efficiency is lost due to the edge recombination, and that can bring down CTM for the module. Next slide, please. Sorry about all the figures due to format error. In JTPV, we developed the HEP process by stacking hundreds of laser cut cells together and depositing a passivation film, usually aluminum oxide, on the affected side to alleviate laser damage. An optional test and sort step on the passivated half cells is followed, and an increase of at least 0.6% in pseudo-fill factor can be achieved. This corresponds to about 0.2% in absolute cell efficiency. Next slide, please. Okay, so I just described them in words, because you can't see the figures. These are our internal results obtained early last year. For both single and double glass modules, HEP can bring about 5 volt improvement in power output, and this is equivalent to a 0.8% increase in CTM. And in the meantime, it also can help reduce breakage and EL problems, since these issues only usually affect 1/2 of the full cell. And another concern for the module suppliers is whether the passivation film will cause wraparound and affect welding or module aesthetics. And our results show that with proper HEP process, the wraparound layer will be restricted to only the outermost 2 to 3 fingers only, and cause no visual difference upon lamination. Next slide, please. Okay. As our HEP process matured during last year, we had several demonstrations from at least 4 tier 1 module suppliers, and we can see that the power increase is even greater than our internal test. In some cases, it can be up to 8 watt. This is attributed to several reasons. First, some module suppliers suffer more severe edge damage during the laser cutting process. In our internal test, we use the so-called damage-free laser cutting facility to minimize edge damage and therefore higher baseline. And second, the HEP thermal process itself can improve VOC and lead to 1 to 2 watts of additional power gain. And the extra benefit is, however, not guaranteed because it highly depends on cell parameters, such as their initial level of defects and passivation. For instance, we find cells with a high level of oxygen defects can be drastically improved by HEP, as you can see from the PL images. So overall speaking, a minimum of 5 watts is repeatable with HEP. Next slide, please. The third feature of mono 2 cells is improved rear optics. From end user's point of view, diverse application scenarios demand power generation using all possible sources, including the albedo, which is the light from the backside. Therefore, it is important to reduce parasitic absorption by optimizing the properties of the rear passivation films. By modulating layer thickness between rear fingers to form an optically inhomogeneous structure, we have improved cell characteristics and achieved the bifaciality up to 90% on the cell level. And we term this technology as wave back surface field, or WBSF. Next, please. Now, this slide shows the results for WBSF. An increase up to 0.15% in front efficiency is achievable with the boosting JSC that overcompensates field factor due to the increased rear lateral resistive loss in the cell. Note that for WBSF, we have a wide range of parameters to choose from. For example, we can change the rear passivation schemes or the percentage of area that receives the treatment. The higher percentage of treatment, the larger the efficiency gain is. But in real production, we must balance efficiency with yield and throughput. And 50% treatment will be a sweet spot. With the use of WBSF, cell bifaciality can be increased by about 6% to reach 90%, as you can see from the table. Next slide, please. The WBSF technology greatly broadens our application scenarios in cases of large solar farms with adequate ground reflection or certain distributed applications, such as carports. The high bifaciality of mono 2 can bring about extra power gain. We've also tested different background materials, including white paint, sand, concrete, grass, or water, and found up to 20% extra power can be generated from the rear side with our mono 2 cells. Next slide, please. So apart from conversion efficiency, reliability is also an important metric for PV module suppliers. We've conducted numerous experiments to facilitate better reliability behaviors from the cell end. Next, please. For instance, we are very careful in selecting silver paste to ensure satisfactory peel strength. Indicators such as thermal cycle, dynamic, and static mechanical load are also well below the IEC standard of 5%, as you can see from the table. So next slide, please. Other reliability indicators such as PID, DH, and UV are summarized on this slide. So for both single and double glass modules, our degradation is significantly lower than the industrial average. For example, for PID 192, our degradation is as low as 1.7%. And in terms of DH, because we refrain from using silver paste with excessively low corrosivity, although they are known to increase VOC, as a result, our DH is generally 1% lower than the industrial average. Over the past year, UVID is a very hot topic for high-efficiency cells and modules, including both TOPCon and HAT. We managed to reduce our UV60 to about 1% with specially tuned silicon nitride layers that not only hamper hydrogen migration, but also lowers transmission for UV light so that the dissociation rate for silicon hydrogen bonds at the interface can be suppressed. Next slide, please. It's pretty, you can't see the numbers on the slide. But earlier this year, we initiated outdoor testing in China. And this site is in northwestern China with temperate continental climate and adequate insulation with relatively high UV components. Starting from December last year, we tested IV characteristics for 2 modules from each stream. And after 4 months of operation, we found that the modules made from our mono 1 cells showed only 0.57% from front degradation, while those from another tier 1 cell manufacturer showed 1.3%. So in terms of total generation per watt, our module also has 1.45 extra output than the competitor. Next, please. Okay. So both modules started off with 580 watt after stabilization, and it dropped to 572 watt for the competitor and 576 for JTPV after 4 months. So for the trend in daily generation in the bottom graph, we can see that the JTPV modules have slightly higher generation per watt, possibly due to better low light performance. And the gap between the two groups became larger as time went on, reflecting the effect of degradation. Next slide, please. Now we can have a glance at our product specs. Next, please. Okay. So first, let's look at the trend in wafer and module size in the industry. According to PV Infolinks, there is a growing popularity for 210R wafers because we can fit 66 full cells or 132 half cells nicely within a standard 2.38 times 1.13 module. And due to the larger total area, such a module has a power advantage about 20 to 30 watt over a 72182N or 1A3R module of the same size. The 66210R modules also have the lowest logistic cost as they make the best use of the standard 40 HC container. Larger module formats such as 66210M modules with over 720 watt will remain at 20% market share in the future. Next slide, please. And this slide summarizes the module power output from our Mono 1 and Mono 2 cells. Both cell types come in a variety of common wafer size and module formats. For the most popular 66210R modules, Mono 1 can reach up to 630 watt, and a further increase of 15 watt can be achieved with Mono 2 cells. So next slide, please. This slide shows the simulation for a 10 megawatt CNI project based in Qinghai, northwestern China, with a temperate continental climate and a very good insulation. The models used for comparison here are all based on the 66210R format and include early TOPCon and our Mono 1 as well as Mono 2 products. Note that the power output here is the average number, not the maximum. So apart from higher cell efficiency, our products also have better generation due to slightly lower temperature coefficient and higher bifaciality, especially for the Mono 2 cell. So taking the early TOPCon as a benchmark and assuming the same module form for all the 3 cell types, the final savings on BOS and LCOE are about 1.5% for Mono 1 and over 3% for Mono 2, showing the cost effectiveness of our products. Next slide, please. Now, I'd also like to share some information about our progress in BC technology. Next slide, please. Apart from TOPCon, we've also put a lot of effort in TBC technology, which is based around passivated contact for both P-type and N-type regions. These cells can reach an exceptionally high GSC around 42 milliamp per square centimeter and VOC above 747 millivolt. And this leads to about 1 to 1.5 efficiency advantage compared to TOPCon cells in the industry. And for a 72196R module, which is made from 196 times 182 cells, the power output can reach up to 675 watt with a high density module layout. In addition, the metalless front side is more aesthetically pleasing than the conventional front and rear contacted products. Though not yet in mass production, our expertise and experience in BC will allow us to respond promptly should the market become more favorable for this high efficiency technology. So finally, some background information about our company. Next slide, please. And next. JTPV is a wholly owned subsidiary of Jinda, a Chinese A-share and Hong Kong A-share listed company with an annual capacity of 44 gigawatt for N-type solar cells, and we shipped more than 38 gigawatt of N-type solar cells during last year and Q1 this year, with a cumulative amount reaching 60 gigawatt. And that concludes my presentation today. Thanks for your attention.
Thanks, Xinrui. Thanks a lot. If there's any questions, please ask them in the chat. Xinrui is with us. Maybe one from my side actually. So you're still a leading cell manufacturer. Explain us a little bit also once again. So where is your focus in terms of products as and where what's your strategy today, tomorrow?
Currently, we're making high efficiency N-type TOPCon cells. The capacity is about over 40 gigawatt, and the annual shipment is about 30, according to last year. And for Q1 this year, it's more than 7 gigawatts, so roughly 30 as well. But we are also for R&D. We've been working on BC since 2023, so almost 2 years, and the BC technology is technically ready, but we're waiting for the right moment to kick in.
Okay, and I think so. So your focus is heavily on the cell, and how is it on the module side of things?
So for the modules shown on I shown on the slide, we just make we ask the module suppliers to make modules from our cells, but we JTPV only make cells. We only ship cells, not modules.
And you stay like that, and you have no plans actually to further integrate into the business. So you stay a cell provider mostly.
Yeah, okay. I think for now we would rather stay professional in cell manufacturing.
Okay, that's great, because that's good to know, because a lot of companies, of course, are integrated up or downwards. So it's good to know that you stay a cell provider. Module manufacturers can rely on you. Thanks again.